Hello, good morning, wherever you are. Today we are learning a new concept about symbol titration. We are learning symbol titration, a new concept about symbol titration. Now, symbol titration, this is a type of titration where we react acid with base, acid and base, or we react acid and carbonate, either acid base or acid carbonate. That's what we call symbol titration. So in this question that we have today here, we are reacting an acid with a base, acid reacting base, and you know the product acid when reacted base, the product is salt plus water. So we have this question, 20 centimeter cubic of 0.5 molar of sodium hydroxide, 20 centimeter cubic of 0.5 sodium hydroxide was reacted with 0.4 molar of sulfuric acid. So in this question we have two major information. We have two solutions here. The two solutions here we have is, let me wrap here. The two solutions that we have here is, we have a solution of sodium hydroxide. A solution of sodium hydroxide. In this solution of sodium hydroxide, we have volume, which is 20 centimeter cubic. 20 centimeter cubic. We also have the molarity of this base, 0.5 molar. We have also another solution called sulfuric acid. Sulfuric acid, they only give us the molarity, which is 0.4 molar. We don't have any other things about sulfuric acid. So the question number 1A is asking, calculate the number of moles of sodium hydroxide. So how do you get the number of moles of sodium hydroxide? We have the volume and we have the molarity. This is what we do. We are solving part A, Roman A. We are solving A. So this is what you do. You will say 0.5 molar, 0.5 moles or molar is equal to 1000. This is how is it. Because I'm saying is equal to 1000 because the molarity of any given value, always equal to 1000. Then you will say 20 centimeter cubic, how much? 20 centimeter cubic, how much is it equal to? We don't know. 20 centimeter cubic, how much is it equal to? We don't know. Then 0.5 moles, 0.5 moles times 20 centimeter cubic, all over 1000, centimeter cubic. So this is centimeter cubic and centimeter cubic, they cancel. Let me cancel it. Centimeter cubic and centimeter cubic, they cancel it. Then what do we get here? We will get it 0.5 times 20 divided by 1000. When you do that division, when you do that multiplication, 0.5 times 20, then you get 10. 10 divided by 100, you will get it 0.1. So the number of moles of this solution, which is sodium hydroxide, is equal to 0.1 mole. So this is the number of moles, 0.1 moles of sodium hydroxide used. This is the number of moles of sodium hydroxide. What have I done it? I have the molarity of the base, sodium hydroxide, and its volume. So molarity is equal to 1000. Molarity is equal to 0.5 mole, which is molarity is equal to 1000. Then what about 20 centimeter cubic? And this is 1000 centimeter cubic, not 1000 only, 1000 centimeter cubic. Then what about 20,000? Then you cross multiply. What you get from there is the number of moles of the base. Then part B. Let us go to part B. Let me make my pen very thick because sometimes you will not see it. Yes, right now it's okay, or it's much bigger. Let me make it the way it was before. Okay. Let's do part B. Part B is saying the number of moles of the sulfuric acid. If you have the number of moles of the base, that reacted the acid, how do you get the number of moles of the sulfuric acid? This is what you do. You react by saying sodium hydroxide aqueous, or let me use this side because here is a little bit, it's not I don't have enough space. Let me use this space. Let me use this space. Let me use that space. Okay, so I will use this space. I will say it, but P, you react the two solutions, sodium hydroxide aqueous plus sulfuric acid aqueous, then an arrow. When sodium hydroxide is reacted sulfuric acid, we will get it sodium sulfate aqueous plus water, sodium sulfate plus water liquid. Now to balance this equation, sodium is 2 here, you put 2 here. Okay, sulfur 1, sulfur 1, sulfur is balanced. So when I'm balancing, I will use the color. I will use colors, like I will use the green colors when I'm balancing. So let me wrap that. When I'm balancing, I will use the green color. So we put 2 here, since we have sodium 2 here. Then hydroxide, when sodium is balanced, then next is non-metal, which is sulfur. Sulfur is 1 here, and here sulfur is 1. It's balanced both sides. Then the next is hydrogen. Hydrogen 2 here, hydrogen 2 hydrogen here plus 2 hydrogen. In the reactant side we have 4 hydrogen. This 2 hydrogen here, another 2 hydrogen here. So the reactant side we have 4 hydrogen. Then here we need to put 2 to make it 2 times 2, 4, balanced. Oxygen, 2 oxygen here and 4 oxygen here, 6 oxygen. Here we have 4 oxygen and 2 oxygen, 6 oxygen. It's balanced. The equation is balanced. Therefore, when we balance the equation, we take the mole ratio of the reactant. So here the mole ratio is always the coefficient of the compound. Here we have 2 to the mole ratio of 1. Here we have 1. The mole ratio of sodium hydroxide is 2, the coefficient. Where sulfuric acid, the mole ratio is, we don't have any value here, we take 1. Therefore, we have the number of moles of sodium hydroxide, which is 0.1. Its mole ratio is 2. Then we'll say 2, which is the mole ratio of sodium hydroxide, is equal to 0.1 mole. What about 1 mole ratio of the sulfuric acid? How many moles will it be equal to? From there we get the number of moles of the sulfuric acid. Okay, let us do it. 2 times 0.1 mole all over, sorry, I have done a mistake here. Let me confirm that mistake. Instead of multiplying this one, we need to do this. 1 can be multiplied 0.1. Yes, cross multiplication. 1 times 0.1 mole all over. Anything that we multiply x, it will go down, divided by 2. Then the answer is 0.005 moles. This is the number of moles of sulfuric acid. This is the number of moles of sulfuric acid. So by confirming the division, let me confirm the division. 0.1 divided by 2, if I'm not wrong, it's 0.05, not 20. We have 0.0510, not 0.05. We have 0.05. When 2 is divided 0.1, that's the value that we get. So that's how you get the number of moles of the sulfuric acid by P. What have I done it? I have the number of moles of the base as 0.1. Then to get the number of moles of the acid, you react the two, you write the equation, you react the two solution, which is sodium hydroxide and sulfuric acid. Then you get the product, which is salt plus water. This reaction is a neutralization reaction. Acid recancels base, and then the product will be salt plus water. Then you balance the equation. When you balance the equation, you extract the mole ratio. The mole ratio is always the coefficient of the product, of the reactant. The mole ratio here in this case is 2 to 1. sodium hydroxide mole ratio 2 and the sulfuric acid 1. Then since we have the number of moles of sodium hydroxide as 0.1 in part A, then you say the mole ratio of sodium hydroxide, which is 2, is equal to 0.1. 1 mole ratio is equal to X. Then you cross multiply. When you cross multiply, then this is what you get, 0.05 moles of sulfuric acid. That's what you get. Okay, let's do it by C. But C is asking the volume of sulfuric acid. The volume of sulfuric acid. In the top part, if I go back to the question, the other part of the question, sulfuric acid, the molarity is always, they give us 0.4. So since we have the molarity of the sulfuric acid, and we have the volume, the number of moles of sulfuric acid used, which is, but P, we got it 0.05, I mean, we can say the molarity is 0.4 molar is equal to always 1000 in terms of volume, 1000 centimeter cubic. So this number of moles is the number of moles of the sulfuric acid used. So it gives us the volume used. So how do we do it? We put it here, 0.05 moles of the sulfuric acid, moles of sulfuric acid used. How much will it be equal to? We do cross multiplication. After the cross multiplication, then this is what we get, 0.05 mole multiplied by 1000 centimeter cubic, then divide by 0.4. Then what do we get it? So let us do that simple calculation. That simple calculation is 0.05 times 1000, then we get 50 divided by 0.4. My mathematical calculation is saying like that, 0.05 multiplied by 1000, it is 50, yes, 50 divided by 0.4, we get it 125. So the volume of the volume is 125 centimeter cubic. This is the volume of the sulfuric acid used to neutralize 20 centimeter cubic of sodium hydroxide. So what have I done it? In the acid, they give us, if I summarize by C, in the acid we have the molarity of the acid, and they're asking the volume of the acid used. How do you get? You take the molarity as 0.4 is equal to 1000. Why? Molarity of any given value in terms of volume is equal to 1000. 0.5 mole, which is the number of moles of the sulfuric acid used that you have obtained through equation, through equation, reaction of the equation, which is this one, 0.05 is equal to how many volume used. This is the number of moles used. Then it gives us the volume used, which is, when we do cross multiplication, we get it. This is the value, 125 centimeter cubic. Thank you. I hope you have understood it. Please subscribe and share.